Hey guys, how's everything going? Today, let's continue our journey to LeetCode. I'm JSer. Let's take a look at number 96, unique binary search trees. So we're given a number n. How many structurally unique BSTs that stores 1 to n? So what is binary search tree? Binary search tree means that for each node, the numbers smaller than it is put to the left, and the right numbers is to the right. The larger numbers are put to the right. So for this kind of tree, if you want to search some number, we just compare to the root and determine left or right, and then do this recursively, and we will find the target, right? Okay. So this question asks us the account of the unique binary search trees. So how should we do it? So let's first analyze the characteristic of binary search trees. As we said, there is a root, and the smaller numbers are to the left, bigger numbers are to the right. So for the very beginning of this tree, the root node, how many possibilities are there? Like for this example, we are given a number of 3. So the root might be first 1 or 2 or 3, right? If we put 1, then the number smaller than 1 is empty. So its left is empty, and the numbers bigger than 1 are 2 and 3. So the question becomes, if the root is set to 1, how many BSTs could be generated from 2 and 3? Of course, this is kind of a recursion, right? So this reminds us of the first recursion solution. We just set the root to each number and do the rest, right? For the left, we will call the function recursively, and for the right, we will call it again. Actually, the numbers values doesn't matter. We only care about the count, right? Okay, so the problem becomes for let I equals 1 and it will goes to n. So, like for number 2, the numbers smaller than it will be only 1, and numbers bigger than it is also 1 number. So the count becomes the count of left multiplied by the count of right, right? It's the full permutation. Okay, so for I, how many numbers are to the left? It will be return, not return. We should sum them up. Okay, so let count equals 0. Count plus, for each root, we will calculate the left tree. Left tree would be trees. I, for 1, there is 0, so I minus 1 times num trees, n minus for 3, for 1 it will be 2, so my n minus I. And finally, it will return the count. So let's continue to the ending cases. If n is 1, how many trees are there? 1. If n is 0, there is only 1, also 1, right? So if n is smaller or equal to 1, then return 1. If n is 2, then it would be 1. Only 1 possibility. 2, 1 possibility here, right? So for 1, 0, this will be 1, so 1. And 2, this will be 1, and this 0 is 1, 2. Yeah, this should be right. Let's run the code. Let's submit. Let's analyze the time and space. Well, we're accepted, but it's slow. We are only faster than 5%. That means 95% of other solutions made by some other people are better than us. So what's the time? Well, it's let's just create some formula here. Here, Fn equals. Of course, for this one would be F1, right? So F0 times Fn minus 1 times F1 plus n minus 2 plus Fn minus 1 Fn, right? Well, this is F0 would be 1, so actually F minus 1 n plus F n minus 2 times F1 plus F n minus 3 times F2 plus F Oh, how should I do this? I don't know. It's F. Now let's transform Fn minus 1. It would be F0 times wow. If you just do some approximation to maximum, it's just smaller than F0, so it's Fn minus 1 plus F1 is also 1, right? F1 is also 1, so plus F2 plus F2 times Fn minus 3 plus blah, blah, dot 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 Fn minus 1 time. Wow, this is hard. So for Fn minus 1, it will be 2 times generated, right? After I thought about this for almost an hour, I gave it up because it's really difficult for me. Please search on the internet. There's it's actually there's actually a very interesting topic for this. It's actually the time complexity would be Fn equals to SCN, means Catalan number. Please search it. I'll just write down the formula. Cn equals 2n Cn and divided by n plus 1. there's actually a very, very deep topic about this. I think I hope in the future, if I have some time, I would do some more investigation and make a video for you guys. But for now, I just remember, I don't think anyone could derive the result from such a short period of time, right? From the deduction formula, actually we can do some pure mathematical things and get the result. I think this looks confusing, so I have to say Catalan. And yeah. This C is the combination, okay? So this is far beyond imagination. This time it's not acceptable. Now we can we improve? Obviously, when we are calculating the result of n, we have used f0 a lot of times, right? f1 a lot of times. So the naive solution would be do some memoization. Let's do that. Function. I think there is some other videos I explained about memoization. We can, and that it's very simple. We use say cache, like new set. If okay, so num trees. We will just to do the same about this recursion. There is no recursion, but yeah, we do a little improvement. It's that if cache has, and then we return it directly. Get n, right? And okay, for here I'll set to cache. So this should also do, and much faster, because we omitted cache set is not function. Oh, map. God, it's map. We avoided calculating the same n for a lot of the times. Let's try to see the result. Yeah, well, faster. Now, this is a genuine, how to say, improvement of the recursion approach. The time would be for each number they actually be counted once, right? So it's linear time. You see, for wait a minute, is it linear time? For n, I would calculate. Yeah, I think linear time. Space. We use this map to so it's also linear time. Yeah, I think that's all for this problem. I think there's some other solutions called dynamic programming, but it's basically the same as this memoization. For this case, okay, for this problem, because we only need to calculate the results. And for that dynamic programming, actually we're doing the same. There's no such thing that you can do a nice trick with dynamic programming. There might be for some other problems, but for this one, it's the same as the memoization. So I'll stop here. I hope it helped. Stay tuned for the Catalan episode. Okay. I'll see you next time. Bye bye.